Hey everyone, happy Thursday. So today we're going to keep going with that same topic, trigonometry. We're just going to kind of start doing those problems now in reverse. And I'll go a little bit more into that in a second here. So if you haven't tried the warm-up, guys, pause the video, try it. When you're ready to see the solution, go ahead and hit play. All right, so it says solve the following equation. So an algebra 1 problem here. First thing that you guys had to do was take care of those parentheses, right? So we're going to go ahead and use distributive property. You should have multiplied 5 times 2x. 5 times 2x is 10x. And then you multiply one more time, 5 times 1. 5 times 1 is just 5. We go ahead and bring everything else back down, 3x minus 2. At this point, I see that I have like terms. I have a 10x and I have a 3x. It's completely up to you which one you want to move over. I prefer the smaller one. So in this case, we're going to get rid of that 3x by subtracting 3x to both sides. Minus 3x minus 3x. Those do cancel out. We bring down negative 2 is equal to 10x's minus 3x's is just 7x's plus 5. All right, we got a two-step equation. It is a little backwards than what we're used to, but we can still do it. How do I get rid of that 5? We go ahead and subtract 5 from both sides. Minus 5 minus 5. Negative 2 minus 5 is negative 7. That is equal to 7x. You got one more thing that you have to do here. The last thing we do is divide both sides by 7. Now be careful here. Negative 7 divided by 7 is negative 1. Negative 1 is equal to x. There is our answer. All right. Moving on to today's work. So trigonometric ratios, day number three. So what we're going to be doing today, so before, I was giving you guys a triangle, right? And I was giving you guys 3 sides, and I was asking you guys to give me sine theta or cosine of theta or tangent of theta. And all you were doing was, as you labeled your opposite, your adjacent, you guys were giving me these fractions, right? You guys were giving me some fractions, something like 1 over 2 or 3 over 2, whatever it was, right? So what we're going to do today is we're going to practice a little bit more, but then we're also going to go backwards. What I'm going to do is I'm going to give you the fraction 1 over 2, and I'm going to ask you if you can go backwards and give me the actual trig function. Which one was it? Was it sine? Was it cosine? Was it tangent? Which of these gave us 1/2? All right, so kind of going in the reverse direction. All right, so let's go ahead and jump into it. So trigonometry, guys, one more time. What is trigonometry? What is trigonometry? Again, it's a branch of mathematics, and it studies the relationship between the lengths and angles of a right triangle here. Now, don't forget, I cannot stress this enough every single time I make these videos, guys. That reference angle is so important. That's basically where you are standing in the picture. That's gonna determine what side is what. All right, what's your opposite? Which one's your adjacent? And again, let me kind of repeat. How do we find that? As soon as you know where to stand, as soon as you know where that theta goes, and I typically will tell you where that theta goes, I would immediately walk across until you hit the opposite wall, and that's what we call your opposite side. The one that I identified next is I find that perfect 90-degree corner. I walk across that one. That is going to be our hypotenuse. We will label that our hypotenuse. If we're ever asked to use the hypotenuse, that's what we'll be using. The last one, of course, is the adjacent. It's the side here that's touching the reference angle other than the hypotenuse. That's why I like to leave that one towards the end. Again, it's just kind of the odd one out, the last one standing there. All right. Now, SOHCAHTOA, guys, SOHCAHTOA, like I said, that's really nothing. That's just a way to memorize. That's just a way to memorize these 3 trig functions here. If I had you guys memorize these just kind of off the top of your head, it does get it is difficult, right? I'm asking you guys to memorize 3 different, think of them as formulas if you want to. It's a little challenging. So this is why we have it's a mnemonic device. It's just a way to remember what is what. Sine right here. If I'm ever asking you for sine of theta, I'm asking you to give me the opposite side over the hypotenuse. You would give me whatever values are there. If I ever ask you guys for cosine of theta, I'm asking you guys for the A, which stands for adjacent side, over the hypotenuse. If I ever ask you guys for tangent of theta, I'm asking you guys for the opposite side over the adjacent. Now again, that's a lot to memorize. That's a lot to memorize. So we got to make our lives easier. And this is why we come up with SOHCAHTOA. It's just a nice way to memorize that. Take a look at the SO part in SOHCAHTOA. It starts with an S. That reminds you that it's sine. And then it has the O and H for opposite over hypotenuse, right? If you take a look at the ka in SOHCAHTOA, the C stands for cosine. The A and the H, that's just to remind you that it's adjacent over hypotenuse. And then, of course, the TOA part, the T stands for tangent. That's just to remind you it's tangent. And this is OA, right? TOA. So O and A, which means opposite over adjacent. All right, that's just, again, SOHCAHTOA is used to help us memorize these three trig functions here. All right, that's just a way to memorize them. So let's go ahead and take a look at problem number 1. This is review what you guys should have been doing for the past 2 days. So I'm going to go ahead and write SOHCAHTOA before I forget, and I'm actually going to write it this way. I like to write it this way instead. SOHCAHTOA. All right, and they're asking us to find what is sine of f. And just like yesterday, we're going to get the fraction and we're going to get the decimal. Okay, so where should I stand? Again, you always want to start by labeling your picture. What's your opposite? What's your adjacent? And you can't just randomly pick one of these and go opposite or that's opposite. No. There is some kind of thinking that goes behind this. I'm asking you for sine, and I'm asking you for sine of angle F. So where do you think we should stand in this picture? Walk yourself over here to angle F, and you're going to go ahead and put the reference angle there. That's your theta. That is you. That is where you're standing in the picture. Now that we know where we're standing, we can go through and actually label. So let's immediately walk to the opposite wall. This 12 here represents the opposite side from D to E. That's my opposite. Let's find that 90-degree corner. Walk across that one. That's always going to be your hypotenuse. Always directly across the 90-degree corner. That is your hypotenuse from D to F in this situation. And then, of course, the last one here, from F to E, the last one standing here, that is our adjacent. Great. Now that we've identified what is what, let's go through and actually just substitute into our trig function. So remember, they were asking us for sine. We're not using the ka part, that's cosine. We're not using the TOA part, that's tangent. We're using this very beginning piece, the so and SOHCAHTOA. And again, why do I write that up there? That's just to remind me. If I asked you right now, hey, what is sine? Off the top of your head, it's a little challenging. So if I look at SOHCAHTOA here, the S reminds me that, hey, this is sine of theta, and that is equal to the O over H. Well, what does O stand for? That stands for opposite over H, which stands for hypotenuse. That's just, again, to help me memorize what was that trig function. What was that formula, if you will. I hate to use that word, but if that helps, go ahead and feel free to use it. All right, now let's just go ahead and plug in what we know. Let's plug in what we know. So here we have sine of theta, no longer going to be theta. Remember, we're standing at angle F. Theta's over here at angle F. Sine of F is equal to, what was our opposite? What did we label as our opposite? That was 12. So we're going to go ahead and write 12 over what was our hypotenuse. Our hypotenuse here was 15. We're not even using that adjacent side, and that's perfectly okay. So there you have it. Sine of F is equal to 12 over 15. Of course, we could actually simplify that fraction, even though that is correct right now. I can simplify. What's 12 and 15? We can divide top and bottom by 3 here. I would want to clean this up. It'd be a lot nicer if I can simplify that fraction to write this as sine F is equal to 12 divided by 3 is 4. 15 divided by 3 is 5. It's a lot nicer to write it in the simplified form. I'd rather work with the number 4 and 5 versus 12 and 15, right? Working with smaller numbers. So there you go, guys. That is the fraction in reduced form. Now let's go ahead and write this also as a decimal. Sine of F. Sine of F. All I'm doing here is I'm going to go ahead and divide 4 by 5 on my calculator, and I get 0.8. 0.8. Again, sometimes it's nice to use the fraction, sometimes it's nice to use the decimal. And like I said, as of right now, guys, you're not solving anything. You're basically just learning how to set up the problems, how to work with SOHCAHTOA, how to identify your opposite, your adjacent, and then plugging into these trig functions. Okay, so there you have it. That should be review from the last couple of days. Okay, so now imagine that problem. Imagine it going backwards. So what I mean by that, let me actually go back to the example. What if I gave you guys, what if I said, hey, which would it be, sine, cosine, or tangent? Which one would give me this fraction of 12 over 15, right? If I said, hey, what gives me 12 over 15? We're going to see if we can work backwards to figure out, hey, it was sine of angle F. So let's see if we can work this out. So it says, what was the trig ratio or ratio? Sometimes there's actually more than one answer. That gives us 30 over 34. I'm looking for, hey, is it sine? Is it cosine? Or is it tangent? That's going to give me the fraction 30 over 4. So this is the way that I deal with this problem. This is what I do. Since they don't tell you where to stand, if they told you where to stand, they'd pretty much be giving you guys the answer. It's up to you. It's up to you. It's up to you. It's up to you. And we're going to have to test it 2 different ways. We're going to have to try this problem out 2 different times. All right. The first time, I'm going to put myself that reference angle. Where should I stand? And remember, you never should stand on that perfect 90-degree corner. You're either going to stand at A or C. I'm going to go ahead and, for the beginning the first time, I'm going to place myself over here at angle A. Now that I've placed myself at angle A, let's walk across and let's start labeling that our opposite side. Let's find that 90-degree corner, walk across that one, label that your hypotenuse. And then, of course, the last one over here is your adjacent. Okay, now that we've labeled, take a look. I was asking you guys, what gives us 30 over 34? And if I look at those numbers, take a look at 30 here. That says adjacent, and then 34 says hypotenuse. If I'm looking for 30 over 34, what has adjacent over hypotenuse? Look up here at SOHCAHTOA. Which one has adjacent and hypotenuse? It is going to be cosine. There's the A, there's your H, adjacent over hypotenuse. So what was the trig ratio that gives us this? It's going to be cosine. And then where were we standing at? What angle were we actually standing at? We were standing at angle A. Cosine of angle A will give you A, which is our adjacent, 30, over our hypotenuse, which is 34. That is one possible answer. That is one possible answer there. All right. So what do we have to do next? We're going to have to reset this problem. So let me erase a couple of things here. We're going to erase. Now, remember at the very beginning, I was debating where should I put this reference angle? I first originally put it at A. Guess what we're going to have to do now this time? We're going to go through and test it one more time, but we're going to test it when theta is over here at angle C. So let's do this one more time. If I put myself here at angle C, let's start to label. Walk directly across. This is now my opposite side. Let's walk directly across the 90 degrees. That's now my hypotenuse. Let's walk directly, or sorry, the last one here is my adjacent, right? The last one here is my adjacent. So notice, a couple of things did switch. This side now is considered my opposite side. Before it was considered my adjacent. This one was considered my opposite. It's now my adjacent. Why did that happen? It's because we're standing on a different angle. We're standing on a different angle. This is why you have to test the problem 2 times. Okay, now let's kind of think about this for a minute. They're asking us what gives us 30 over 34. Well, if I take a look first at 30, right, the top number, 30 here. If I find it in my picture, 30 represents my opposite. Which ones have opposite up above? Well, I see O and so, and I also see the O in tangent. Okay, so it's going to be either sine or tangent. Now take a look at the next number, 34. If I find 34 in my picture, there it is. That one says hypotenuse. Which one says hypotenuse? A in tangent, that's adjacent. The H in sine is my hypotenuse. I'm not going to be using tangent. I'm not going to be using cosine. So which other answer, which other trig ratio gives me 30 over 34? It's going to be sine. Sine of what angle now, though? Sine of, where were we standing at? This time we were standing at angle C. Sine of angle C is equal to your opposite, which was 30, over your hypotenuse, which was 34. There you have it, guys. Those are the 2 answers that we're looking for. Sometimes you'll only get one. Sometimes you get 2. That's why you always want to test at least both angles, right? Put yourself at angle A, put yourself at angle C, and test it both times. Test it both times. All right, let's move on and try example number 3. If you want to try it on your own, pause the video here, and then when you're ready, go ahead and hit play to find out the solution. All right, so let me begin, guys, by writing SOHCAHTOA one more time. SOHCAHTOA. All right. And they ask us, what was the trig ratio that gives us 21 over 28? And again, they gave you guys this picture, but they don't tell you where to put your reference angle. They don't tell you where to stand. So you're going to have to test this 2 times. You're going to have to put yourself first at angle Z, and you're also going to have to put yourself at angle X. You're going to have to do pretty much 2 problems. Yes, oh my gosh, no, it's not the end of the world, guys. It's not the end of the world. It's 2 problems. Relax, you'll be all right. So let's begin by, and again, it doesn't matter which one you try first. I'll start over here at angle Z. If I wanted to stand on that angle, let's start labeling. Let's walk directly across and label that as my opposite side. Let's walk directly across the 90 degree. That's going to be my hypotenuse. And then the last one down here, of course, is our adjacent. And again, a couple of these things will switch when I put my reference angle over here for the second time on angle X. All right, let's look at the fraction now. Let's look at the fraction that they wanted us to get. 21. Let me focus on that 21 first. 21, if I find it, that says opposite. Which of these has opposite up above? Well, sine and tangent. So it's going to be one of those 2. We can already kind of cancel out cosine. It's not going to be cosine. Now let's take a look at the next number. 28. Where's 28 at? 28 is my adjacent side. Which one has adjacent? That is not going to be sine. Sine has hypotenuse. It's tangent that has the A. So what was the trig ratio that gives us 21 over 28? We were standing at angle Z and we were using tangent. So we're going to say tangent of angle Z is equal to 21 over 28. That was one possible answer. Guess what we have to go through and do now? We're going to have to go place ourselves. So let me erase, not everything completely, so I can show you guys what I'm doing here. I'll erase SOHCAHTOA. I can write it again. It's good practice. SOHCAHTOA. Okay, so if you remember, for the first time that we tried this problem, I put us at angle Z. All right, great. This time, let's go ahead and put ourselves at the other one. And again, you'll never put yourself on that perfect corner. You'll never put yourself on that 90-degree corner, so don't do that. Let's try it out if I put my reference angle at angle X. Let's immediately walk across to the opposite side. 28 now is opposite. Across my 90 degrees, that 35 is my hypotenuse. And then adjacent here is going to be 21. Go back and look at the fraction that I asked for. I was asking for 21 over 28. Let's just focus on the 21. So 21 right now, if I circle it over here, that is adjacent. Which of these have adjacent at the very top of their fractions? Well, that right now is saying cosine. But be careful. Take a minute, please. Just because one matches doesn't mean it's actually going to be the answer. Take a look at the bottom number here, 28. 28. Where's 28 at? That is considered my opposite side. Does cosine say adjacent over opposite? Do any of these say adjacent over opposite? None of these here say adjacent over opposite. Cosine got very close. It was adjacent over hypotenuse. But guess what? None of these work out. So there's actually only one answer. Tangent of Z is the only way you're going to get 21 over 28. But we still have to test this one out. We still want to test it out. It might be a possibility. We still want to kind of try that problem one more time. All right. So let's get into example number 4. All right, this time you guys will actually have to build a triangle, and we're going to have to use a little bit of Pythagorean theorem. This is why we were practicing Pythagorean theorem. A squared plus b squared equals c squared a little bit earlier this week. So it says if sine of theta is equal to 24 over 40, then what the heck is cosine? What you want to do first then is draw yourself a right triangle, and again, it doesn't matter which way it's facing. Do the best you can. That's not the prettiest in the world, but we get the idea. There's that perfect corner, and now what we're going to go ahead and do is we're going to start to label, and it's up to you. Since you're creating this triangle, you're drawing yourself the picture, you can put your reference angle up there or down below. I think it's a lot easier visually if we put it down here. And let me just start to kind of label. Let me go directly across from that, label that my opposite. Let me find that perfect corner, walk across that, let me label that my hypotenuse. And then, of course, that bottom one down here is my adjacent. So I just drew a generic right triangle, guys, and I labeled my opposite, my adjacent, my hypotenuse, and I went ahead and I put my reference angle. Why did I do that? Why did I do that? Well, let's go back and take a look at SOHCAHTOA. SOHCAHTOA. Take a look at, well, we're not even going to use cosine right now, or tangent, so you can kind of ignore that for a minute. Take a look at sine. Take a look at sine. Sine is O. What does O stand for? So the top of this fraction, this right here, is representing O, which stands for opposite. So guess what we're going to label over here? 24 in my picture. Find your opposite side. Go ahead and put 24. And then, of course, sine, the bottom number of that fraction, that is H. H down here, that represents your hypotenuse. So guess what we're going to go? We'll go ahead and plug in 40 into my picture, right by the hypotenuse. Okay, so my job now that I have this picture, is I want to, let me kind of break this up. I want to figure out what is cosine of theta. Cosine of theta is equal to, if we look up here, it's adjacent over hypotenuse. Okay, do I have enough information to write my answer? Go back and look at your picture. Do we have adjacent? Dang it, no, we don't. Do we have the hypotenuse? Yeah, we do. So how the heck can I get the adjacent? As soon as I find the adjacent, I can actually figure out my answer. I can actually go ahead and write my answer, but we need to first figure that out. How could I possibly figure out this bottom side of the triangle? Let me redraw that triangle one more time, see if it kind of jogs your memory. You have this right triangle. You know that the hypotenuse here is 40. You know that the opposite side here is 24. Doesn't this look like a squared plus b squared is equal to c squared? This is just a middle school problem. If I'm asking you guys to find that missing side here, it's just, you're going to use the Pythagorean theorem. A squared plus b squared equals c squared. So I'm going to go ahead and label it. Remember, please label your hypotenuse first. That one should always be the letter C. So here 40 is going to be C. 24, you can call that A or B. It's completely up to you. I'll call it A. And then this bottom side that I'm trying to find will be B. Let's plug in everything that we know. A squared, that's going to be 24 to the second power plus B squared, because I don't know what B is. That's what I'm trying to find. And then C squared, my hypotenuse squared, which is 40 to the second power. All right, let's take out our handy dandy calculator. 24 times 24, 24 to the second power. That gave me, let me change colors here, 576 plus b squared equals, what is 40 times 40? I think that's 1,600. It is 1,600. It's always nice to double check. 1,600. All right, great. If we keep solving it, we're going to subtract 576 from both sides, and we end up with b squared is equal to 5 minus 576. This gave me, whoops, that's a 6, 1,024. All right, we got one more thing that we have to do. If I can unlock my calculator, because I need to find the square root, and it's not working. There we go. So now remember, how do we get rid of the power of 2 there? In the top of that b, we take the square root of both sides. The square root and the square cancel. B is equal to, the square root of 1,024 is 32. Hey, it's actually a nice number. 32. This b right here, that side of our triangle measures 32. If I actually go back to the original, I can go ahead and write 32 for our adjacent. Now we have all the information that we need to find out what cosine is. Remember, the original problem was asking us to do cosine of theta. Did we have to do a little bit of side work over here? Yeah, you have to do a Pythagorean theorem problem. It's a squared plus b squared equals c squared. But now we can actually write cosine of theta. So let's actually write it. Cosine of theta is equal to, what's my adjacent? Adjacent here is 32. Over my hypotenuse, what's my hypotenuse? 40. 32 over 40. And that's okay. We're going to leave it like that. Yes, we could simplify that, but we're just going to go ahead and leave it like that for now. Cosine of theta would be 32 over 40. All right, moving on to the last one here, guys. So again, take a minute, try this one out. Go ahead and draw yourself that triangle, right? You create that triangle. Go ahead and start to label, right? Go ahead and start to label. And then use that little Pythagorean theorem to find that missing side, because you're not going to be able to find sine of theta right away. All right, when you're ready for the solution, go ahead and hit play. All right, so let me go through, guys. Draw my triangle. There's that perfect, yeah, that's not pretty. There's my perfect corner. Let me put my reference angle there and start labeling right across my reference angle. That is my opposite side. Let me find that 90-degree corner, walk across that one. That is my hypotenuse. That means the last one down here is my adjacent. All right, great. Let's start throwing numbers into this triangle. And remember, let's use SOHCAHTOA just to remind us. Right, this is just always nice to remind us. SOHCAHTOA. So they're looking for, or sorry, they gave us tangent. So they gave us this information here. They say tangent of theta is equal to 40 over 30. So if we're using tangent, the top one here, the 40, is O, or in other words, that's your opposite side. So find your opposite side. Go ahead and put 40. All right. The bottom number is A. This bottom number is A, which stands for adjacent. So find your adjacent side. Go ahead and put 30. All right. Now that we've plugged in everything that we know, we filled in our triangle, can we find sine of theta? And let me use a different color that stands out. I want to make sure it pops so you guys can see it. Sine of theta, right? That's what they were asking us for. Sine of theta is equal to, take a look at sine, O for opposite over H for hypotenuse. Do I have enough information? Well, I know my opposite. My opposite is 40. That's great. I can quickly plug that in. Do I know my hypotenuse? Because I'm going to need my hypotenuse. I don't. So again, we have to do a little bit of side work here. It's just a quick Pythagorean theorem. And again, do you have to draw this triangle one more time? No, I'm just trying to draw it so I can kind of break it apart for you guys so you guys can visually see what's happening. So this side here was 40. This side here was 30. And I'm trying to find the hypotenuse. And remember, that hypotenuse here is going to be the letter C. All right, I don't care which one you put as A or B. I'll put A for 40. I'll put B for 30. Let's go ahead and use Pythagorean theorem. So A squared plus B squared is equal to C squared. This is going to be, if we plug in everything correctly, A was 40 to the second power plus B, which is 30 to the second power, is equal to C, and that's what I'm trying to figure out. So what's 40 squared? I'm going to be 1,600. Hopefully I get that right. Plus, what's 30 squared? That's 3 times 3 is 9. That's 900 is equal to C squared. If I add those two together, that gives me 2,500 is equal to C squared. All right, I got one more thing that I have to do. Take the square root. The square roots of, whoops, those cancel out. The square root of 2,500 is going to be 50. 50 is equal to C. That side that I was trying to figure out over here, this side right here, this hypotenuse is 50 units. So if you go back to the original problem, we can go ahead and put 50 for our hypotenuse. I know all three sides now. Do we have enough information to actually answer our question? Yeah, we do. We're going to write sine of theta is equal to, what was the opposite? Opposite was 40. What was our hypotenuse? Our hypotenuse is 50. And again, yes, I realize that we can simplify that, but I'm going to go ahead and leave it like that for now. I'm trying to keep this video short. So I'll take that as the answer, guys. So don't stress about simplifying. As long as you can get to this point, that's a big win. All right, guys. So I believe that was the last one. Yep, there we go. So let me kind of explain what you guys are doing here. This is your class activity, guys. For the first couple here, or where to go? Oh, for these first four right here, you are finding, right, you're trying to find that trig ratio. So again, place yourselves right at one angle, then reset the problem, place yourselves at the other, right? Place yourself at the first angle, reset the problem, place yourself at the other. These two over here, Problem 3 and problem 6 are like the last two examples that we did. You're going to have to create your own triangle. You're going to have to use a little bit of Pythagorean theorem before you can find those sine of theta and cosine of theta. All right, make sure this is done, guys, on a separate piece of paper. When you're done, check your answers with my sub. They should have the answer key. If everything's perfect, go ahead and submit that into the inbox. Make sure your name and date is on it. All right, guys, take care. Adios.